Okay, while everyone's filing in, I'll go ahead and introduce myself. My name's Kevin Lawson. I'm a registered professional engineer. Before I started Ripple, I had about 12 years of experience in consulting engineering. So I've ran a lot of load calculations. And it was always so frustrating to me because I knew the data that I needed to run the calculations was just sitting right there in the model, but I couldn't get access to it. And I was stuck, hand measuring windows and manually typing them into trace. So it was time consuming, it was boring, it was riddled with errors, it was very error prone. So I kind of began looking into ways and how could I get all of that data out and actually use it in my load calculations? So I'm going to do a demonstration on how to use the toolkit and how to run loads in Revit. You've got a bunch of different options. I'm going to go over one of them. And hopefully you guys can use this. So the Ripple toolkit, we've worked out some sponsorship agreements, so it's totally free to use. So feel free to download it and start using it whenever you need. If you have any questions as we go through, feel free to type them into the chat, and I will try to get to them as we go through. Or if not, I'll get to them by the end. So let's get started. Let me share my screen. Okay, so what Ripple is it's a data aggregator. It's not an actual loads calculation engine. It is really meant to get into Revit, grab all of the data that you need to run load calculations, and then give you the option of what you want to do with that data. And also review the data. So a lot of the data in a model is what I call curated. So somebody else has paid attention to its accuracy. So for instance, windows. So the architect really cares about the window size and shape and orientation in a building because that affects his construction documents. If they aren't right in the model, they aren't right on his construction documents, and you've got real problems. So the window size, shape, and orientation is something that we would like to use in our load calculations. The architects typically don't care about the thermal properties of the window. So that's something that we want to override. Same things goes with electrical light fixtures. So a lot of times electrical engineers will use the wattage on their light fixtures to circuit them. So they have curated and verified that the wattage on their light fixture is correct. So we want to look at that data and use it in our loads calculation if it is correct. So the point of the loads toolkit is to grab the data, verify it, and use it as necessary. And I'm optimistic about this workflow getting better and better and better and better. More and more architects are building higher and higher quality models. I mean, I've seen architecture firms go from, swearing that they're never going to use Revit to producing high quality Revit models that you can run loads on almost a year later. So architects are really accelerating their use and they're building better and better models. That being said, not every model is going to be high enough quality to get quality loads out of. But the number one indicator of that is rooms. If the architect is using rooms, that means they're bounding their spaces good enough to contain spaces. So if the architect has rooms, you could probably get some pretty good data out of the model. And once you get that data out of the model, you have a bunch of different options. So I like the out of the box heating and cooling loads built into Revit. That has been taken out of the default GUI in Revit 2022 and beyond, but there is a way to get it back. You just have to change your settings file, and there is a link on how to do that on my website. So I will put that in the chat, and I'll shoot you guys an email with it at the end of the chat. But this is not your only option. There's also an Energy Plus integration, and this is kind of a newer thing with Revit. And this is called an analytical energy model. And that uses, the go-to Energy Plus model to where you can actually run loads and an energy model. And there's, GBXML exports. You can export a GBXML and import it into your favorite loads tool. You've got a lot of different options, and Ripple really helps you with all of these options. So the analytical energy model, that pulls information out of the space. So you need, your space is defined, which Ripple helps you with. Whichever load calculation method you prefer, I would suggest getting in the habit of pulling that data back into your spaces. So if you export a GBXML and go to, carrier HAP, I would develop a workflow where you can pull your CFM and loads back into the space, because that sets the baseline for further automation. So Ripple's next tool is going to be, automated diffuser layout, which requires the CFMs to be assigned, and then automated VAV selection, which requires the loads to be assigned. So I whatever you choose, I would get that workflow to where you're pulling that data back into the space. I'll be doing this demonstration with just the standard heating and cooling loads, but that's a very small part of, the data aggregation that Ripple does for you. So with that, I say let's get started on the demo. So this is the, Revit sample project that just comes with, any install of Revit. So I've linked in an architectural model, and I've copy monitored over my electrical devices and my lights. So depending on how your firm works, if you have a separate electrical mechanical model, you might need to copy monitor in your outlets and your lights if you want to use those in the load. So the first step is getting the project set up properly. Now the settings for, the spaces and the energy model are kind of distributed all over. They're in a bunch of different settings boxes. So the first tool is a set recommended settings button, and that just finds all the settings and sets them to where you can get good load calculations. If you're interested in what those settings are and how they're set, you can hover over it, hit F1, and it will take you to a website that tells you what all those spaces are and what those settings are. So now that we've got our settings set properly, the next thing is getting good spaces in here. And this out-of-the-box Revit is kind of tough to do. So if you use out-of-the-box Revit and you drop a space in here, okay, it looks okay on plan view, but now let's go to elevation view, and we see that it's not encompassing the entire space. So it just comes in at a default height no matter what the space is. So if I were to run loads on this space, I would be missing all of this exterior area here. The lights would not be included in the space. And it would be missing enough to where my loads would look, pretty obviously wrong if I just use the out-of-the-box space placement tools. So, and then the other problem is plenums. So a lot of times these ceilings are space bounding. So if you drop a space in here, it's going to stop at the plenum, and you're not going to get any plenum load. So it's very time consuming and frustrating to go through and have to put a level at each space, or at a level at each plenum, go and place a space in those plenums, and then set the upper and lower bounds correctly. So we've automated that process. Delete this space out here with our rooms to spaces button. So that's just going to go to all the linked models, grab all the rooms, and place spaces where the rooms are. And then it's going to copy the name and number over, and then it's going to look at what's above the space and set the height properly. So if you have a really tall space, it's going to set the height really tall. And if you have a plenum space, it's going to put a level in that plenum and drop a plenum in that plenum space, and then set those heights properly, automatically without you having to do anything. So we're going to process all those spaces, and it kind of tells us what the result is. So it placed 90 new spaces and 40 new plenum spaces. This gives you a rough idea of the project square footage, the average space height, and it kind of gives you an idea of, hey, does the architect have all the spaces in here? Am I missing some square footage? All that good stuff. So let's hit OK on that. And then let's go and let's look at the section view again. So there you can see it looked at what these space sizes are and it set them properly. So now you've got everything encompassed. All of the exterior wall is encompassed. You've got plenum spaces placed. You're ready to go from a geometry point of view. All of this data can be pulled in and pulled into the loads engine or exported into a GBXML, whichever you want. So these can all be scheduled. So these schedules come with the Ripple Loads Toolkit. When you install it, when you open it, you'll get a new tab and you'll get some new schedules here. So these are space schedules. They're scheduling all the spaces and all the data associated with it. So the next step to getting loads would be to assign space types. So, normally if you weren't using Revit, like if this were an AutoCAD job, somebody would make a schedule like this manually, and then you'd have somebody go through and they'd assign all the space types. So they'd go through here and they'd select all the space types, and they'd have to do it one by one. It's very time consuming. And that is why we made the assign occupancy category tool. So the assign occupancy category tool goes through and it looks at the space name from the architectural model. It looks at the area and it tries to parse, based on ASHRAE 62.1, what this space actually is, and then assign it. So it goes through, reads the name, and assigns a space type, and then gives you kind of an understanding of, hey, what is this building? So this is, most of these spaces are classrooms. This is a school building. This looks right. And you could go through and you could change, if it got something wrong, you can change it. But let's dig in a little bit deeper on these space types just to see what information they contain. So when you install the Loads Toolkit, it comes with all of the ASHRAE 62.1 space types pre-built for you, with data set to it. So let's look at like maybe an office or something. So it gives you your occupant density, heat gain per person, lighting load density, power load density, and outdoor air per person and per area. So these have come from, I've set these up to come from ASHRAE 62.1, from the energy code, and then just from my kind of personal experience of what these are typically at, to get you started with something. Now, if your company has a different assumptions on these space types, you can change them. So if you don't think an office is 1.5 watts per square foot of plug load, you can change it to whatever you think. And if you change this in your template, then anyone who starts a project with your template will have your company standards ready to go for these space types. The other thing you'll notice about these space types is this is a great start, but you're missing a lot of data. There's a lot of other stuff that we would like to assign to these space types that we don't really have access to, and there's no way to assign a new parameter to it. Exhaust area is the one that always frustrated me. I've got these 62.1 space types assigned. Some of them require exhaust. How do I show that here? So what the Loads Toolkit does is it comes with a key schedule, and it's called space type additional data. And the toolkit in the background, anytime you change the space type, it will automatically sync the space type to this key schedule. So you can add more data to the space type. So I've added things like default space temperature set points, exhaust rates, and then, air class classification from ASHRAE 62.1, nodes from ASHRAE 62.1. And then two other parameters called provide supply air and return air by default. So, most of the time, class 1 spaces, you want that air returned. So you check that here, and that way the loads toolkit knows to set the return air parameter for that space. And then sometimes you don't want to provide supply air, like plenums. I don't want to provide supply air to plenums. So this is unchecked for plenums. Electrical equipment rooms, things like that, exhaust driven spaces, you might not want to supply air. So we allow that, you just set that. But this is what I've included, but you can include anything you want, not just HVAC, but anything like fire protection, GPM per square foot. Then you can make, you can assign a GPM per square foot to each of these space types, then make a new schedule and get your fire protection calculations done quicker. So whatever, however you want to add this, or, whatever data you want to add to this, to your space types, you can just use the schedule to do it now. Now you have to have the toolkit installed to make sure that the space type syncs to this key schedule, but it adds a lot of power to your space types, which is really good because your space types are automatically assigned. So it gets a lot of data in the model quickly just based on the architectural room name and area. So these space types, as we went through, they've got a lot of internal load information, just watts per square foot assigned to them. But there's also actual loads, and these are actually read from the elements in the model. So our lights, for every light in the space, it counts up all the lights, gets the wattage off the connector, and puts it here. So if I want to use that, if I want to use the actual lighting load instead of what just my space type is, I can change it to that, and it will use my actual lighting load. So depending on where you are in the project, or how good your electrical engineer is, if they don't use their light fixtures to circuit, then you probably won't have anything here, and so you'll want to by default use by space type. So now if you have to do it manually and you have to count their light fixtures and figure it out, you could also specify your own. So that was, by space type, that was 290. Let's say I go through and count and it's actually only 200. I can set that manually however I want. Let's go to by space type. So what you would really want to do here is you would want to go through, and depending on the phase, you'd say, hey, if I've got a reasonable lighting load, then use the actual lighting load if it's reasonable. So that is what the set internal loads button does automatically, is it goes through and it compares these values. And if the actual load is at least 75% of what I was expecting from the space type, it sets it to use actual load. So it does that for lighting and plug load. So this is read from the receptacles. This is read from the light fixtures, and it tells you where it did it. So now you can kind of see what spaces are you using the actual load, what spaces are you going by space type. If you just want to use your default watts per square foot from the space type, just don't run this button. Just leave that leave that empty, and everything will be by space type. The other thing is there's no person element in the model. So what the internal loads button does is it looks at the furniture in the model and it tries to get a person count based on the furniture in the model. Now, this is really hit or miss depending on how well developed the furniture model is. But it does the same thing. If I count, 75 chairs and there should only be 50 people in here by the space type, then it'll set this to a number of people. So it helps you there. So this is just a really good schedule to get your internal loads, pulled in, verify them really quick, and override them. And it's really helpful too. It's regardless of if you're going to use your by space type or actual load values, it's still helpful to compare what you're assuming to what the electrical engineer is assuming. So this has saved me a couple times where, the architect will call it a closet, and I'll think, I won't think anything of it. It doesn't need any air. I'm not worried about it. And then I'll see that the electrical engineer has a 2 kW plug in the closet. And it's like, okay, what is going on there? And you realize, oh, this is a server closet. I need to address this from an air conditioning perspective. So it's helpful, regardless of if you're going to use it or not, to have the actual loads, butted up right next to what you're assuming. So let's go back to these space types and just go through all the data that in there. So area per person comes from 62.1. Heat gain per person just comes from ASHRAE fundamentals. Lighting load density comes from the energy code. Power load density comes from basically my experience, what I have seen in these space types. The schedules for the load calculations, I like to keep those all at 24 hours, just because I like to know that the watts that I put in end up in the load calculation engine. I don't want, peak solar load is at 10 a.m. I don't want to assume, 20% lighting power at that. And then outdoor air comes from ASHRAE 62.1. And then air changes per hour, 62.1 doesn't have this at all. So this is 0 for all of the built-in ASHRAE 62.1 space types. Okay. So now we've got our geometry defined, we've got our internal loads defined. The next thing we need to define is our thermal properties of our constructions. So this is something where I have never seen an architect actually add this data properly or reliably. So this has to be overridden almost all the time. So the way this is done is in your energy settings, you've got a schematic types, and you could click that and you can change this, and you can override everything here. So every space is assigned to construction type building. This is the construction type, and I have everything set to overridden, and I've got my energy code minimum constructions placed for all of them. But the out of the box way to do this was to just scroll through here and look at, their short description of what the wall is and their U value. And sometimes these are not great descriptors, and sometimes these U values are wrong on the ASHRAE or on the Revit out of the box stuff. So what I built was a manager that allows you to view and edit those constructions. So you could have your own overrides as you see fit. And even if you don't want to add your own overrides, it'll at least allows you to see what the assumptions are. So like this is a out of the box Revit construction, and they call it brick block wall. But when you actually look at what it is, what they're assuming way more than a brick block wall. They're assuming insulation, air spaces, surface resistance. It's totally not what you would assume. So you can go through and at least see what they're assuming, and you could sort these by R value or thickness, or however you want to get to what your wall construction is. The other thing that the toolkit comes with, it comes with your code minimums for constructions for all the zones. So these just come pre-built from ASHRAE 90.1. So this is what ASHRAE 90.1 assumes, and these are pre-built. That way you could, if you don't have good information on the constructions, you can still get a load just by assuming code minimum. And that, as time goes on, that is pretty accurate. Code minimum constructions are so good that most architects aren't beating them by much. You basically just meet them, and that's a great, a great construction. So it's really consolidating what your loads are, where in the past you had architects that were all over the map with their solar heat gain coefficients, or their wall constructions. Now it's kind of forcing everyone to make really good constructions, which is really consolidating how the loads. So the loads are getting more and more consistent. You can look at windows and skylights too. These have different information, and you can add this stuff as well. So constructions are composed of lists of materials, just like train trace or most other things. So let's say we want to add a material. So let's say this is we've got an addition to an existing building, and we want to make that wall. So let's just make a fake wall here. So let's say they have a 1/2 inch of extruded polystyrene. Let's just call it 1/2 inch XPX, and we'll just call this existing wall. So I've already made a bunch of these, so I kind of know what what these are. So our value is going to be 2.5, thickness is going to be 0.5, that's 5 per inch. And you could look at your other materials and see, hey, like foam insulation, 1.3 pounds per square foot, 1, and then it calculates your thermal mass. Let's put continuous insulation here, just so we know it's not, there's no studs or anything like that. So we add that, and it's going to give me a pop-up to, modify your constructions.xml. Now, if we want to add that to a wall, say we're just going to do a fake brick wall. So let's just call it test project, existing wing wall. We're just going to do that by test project. So let's say this has some brick, and then here's our 1/2 inch of XPX, and we're going to make this an exterior wall. Now, I know this is a fake wall. Obviously, there would be drywall and all kinds of other stuff here, but let's just do this for the purposes of showing you this. Add, yes, instructions. So everything's set to the building. So let's go to these spaces, and let's say this is our existing, let's say these are our existing walls where we've got this bad wall. So we're going to select just the spaces, and we're going to go to our constructions. And so everything's now set to code minimum, but we're going to make a new one, and we're going to call this existing wing. And so let's just assume for the purposes of this that they're replacing everything with code minimum except for the walls, or leaving the walls as is. So we're going to go ahead and overwrite everything to building except for exterior walls. For exterior walls, we're going to go to our new test project existing wing wall, and we're going to overwrite it to this instead of the code minimum. So now when I look at my loads, I see that, okay, hey, these spaces don't have the building construction type, they've got the existing wing construction type. So that allows you to put separate override constructions on each individual space, which is pretty powerful. And the way you set the building to your code minimums is just through the set code minimum construction types. So Ripple comes with the code minimum construction types. It looks up your climate zone based on your zip code, and it sets your code minimum construction types. Okay, so now we've got our space geometry accounted for. We've got our internal loads accounted for. We've got our constructions accounted for. The next thing we need to do is run loads. And like I said, I like the default heating and cooling loads load engine. I wrote an ASHRAE journal article that validated the output of this. And if you get all the data in properly, it gives you a great result. So it's just I think that Revit loads haven't been taken up because it's hard to get all the data in there. You got to build your own schedules. You got to go through and set every height of every space. It's just way too much work for something that you don't know if it's going to work right or not. So this works great if you get the data in right. So these settings were all set based on, the first button that is, set default settings. There is a button here that you should be aware of. This is called the use loads credits. So I always suggest leaving this unchecked. So this will, basically, it will take credit for like sun coming through the window when you have heating loads, for your heating load. So, when I've ran loads, I've never done that. I always assume peak heating load it's midnight and it's, whatever temperature is outside. I don't want to assume any sort of solar credit for that. So I always leave this unchecked. You could look at the details. So you see we've got a full space. We've got, full model here. We don't have our, we don't have any errors, but this will show errors if there are errors. The most common error has always been the space isn't bounded by a ceiling or a roof, because the, out of the box space placement tool leaves them really too short, and they don't get encapsulated. So you can even look at the surfaces. You just have to click the analytical surfaces, and it parses all the geometry, but it allows you to scroll around and find these. That way you can look and see what your walls, your windows, everything is. And these all the areas that are assumed here also come through on the report side. So I'm just going to go ahead and hit calculate. And that takes a little while to calculate, just like any loads engine would. But the great thing about the built-in engine is that it takes your loads and assigns them right to your spaces. So it's just one smooth workflow right through, and gets you set up and ready for the next automation tools that are going to come through. So it gives us a good loads report. So it gives you the areas that it's assuming. It gives you the load associated with those areas. It gives you a bunch of good information. And this is a great, save it in the job folder. And if you ever have an AHJ asking about loads or something, it gives you a really good loads report to, print out and have. Let's go back to loads and this is another great thing to save in the job folder. Along with that loads report, here's all your internal load assumptions, here's your total load, and here's your total calculated, heating load and cooling load. Now, the built-in engine does a great job getting the load assigned to each space so you can schedule it. It doesn't do a great job with the airflow. So it adds a couple silly things into the airflow, and then the airflow is never rounded. So like, I don't want to assign 2,664 CFMs to, 8 different diffusers. I need a nice round number. So the last tool is round and override CFM. So, you could set a minimum CFM. Most times I see this set to 25 or 50. And then you can round CFM to the nearest 5. So that's what I always do. So let's just go ahead and onto this. Okay. So based on my load, I've got nice round CFM numbers. I'm ready to start laying out diffusers. Let's do the other thing. So that's great for supply airflow, but let's look at exhaust airflow. So like I said, from the additional data key schedule, I could add all kinds of other information to this, like exhaust rate per square foot. So that's what this copy print, these copy print rooms have a CFM a square foot. And now I can specify, I can automatically get that exhaust airflow specified to each of the spaces that need it. Now notice I didn't spend any time with any of these spaces. The toolkit just knew that they were toilets based on their names. It knew they were copy rooms based on their names. And it knew, based on the key schedule, how much exhaust it should get. So it just automatically gives me my specified exhaust airflow. And there's another schedule that's the airflow check that goes through. And now it's got your supply airflow and return airflow too. And remember how I said with the additional data, do I want to return that airflow or not? So as I set the CFMs, it will set this to the supply air where I know that I want to return air or not. So prep dish and cafeteria are class 2 spaces. I don't know if I want to return that air or not, but I do know that I need to exhaust the prep dish room. So I've got that there. So you're back in manual mode. You can override all of this as necessary. But very quickly, you've got CFMs assigned to the spaces. So let's go to the loads. And then the last schedule here is what I just made a schedule called the space ventilation estimate. This schedule will be enhanced and added to as the VAV selection tool is made, but you've already done all the work. You've got all of this data in for ventilation calculations. Might as well give you a schedule for it. So here's just a schedule set up with all of the, number of people, outdoor air per person, outdoor air per square foot, and the area. So you can export this to a spreadsheet and, however you want to do ventilation calculations from there. But we're going to delete all of these spaces. And the last button is the easy button. So the easy button just goes through and runs all of these functions in a row. And at the end, you have CFMs assigned to all of your spaces. So this takes a while to run, but my hope is that, as you get comfortable with architect's models and the toolkit, you can run this, go grab a coffee, come back, and you can have CFMs assigned to your space and ready to go. Then the last button that we did not talk about while this runs is the architectural element finder. So the architectural element finder will actually look at all of your spaces and find the actual architectural element and the materials that compose it from the architectural model. So if you did have an architect that you work with a lot, and you might want to say, hey, let me get their materials library, let me get their thermal properties in so that I can just use the actual architectural model. So again, I have never seen an architect get this right. But if you're curious to see, hey, how many material types is the architect actually using, you can use that to get, just explore the whole model and get a quick feedback of, hey, how many materials would I actually have to go fix to get to a point where I could use their actual elements. Okay. While this is running, I'm going to go and I'm going to read through some questions to see, hopefully I got some of it. Can the constructions library be updated to California Title 24 code minimums? Yes. That's something I don't have built in out of the box. I just focused on the energy code. But you can certainly add, as we showed, you could add whatever space types that or whatever construction types that you would like. Which makes the constructions manager it allows you to override with anything you want, and it allows you to build a library. It's very similar to some of the classic loads engines like train trays. Okay, from a Revit 2022 standpoint, how are you pushing your construction overrides into the Energy Plus calculation? I have not dug in to the Energy Plus integrations too deeply, but I'm pretty certain that the construction overrides work the exact same way. That if it's overridden, the analytical energy model will pull those space constructions. Just like it pulls the internal loads from the spaces, it's also going to pull the override constructions from the space. So I believe that's, out of the box Revit functionality is to pull those overrides. This would just allow you to add your own constructions and view, the assumptions of all the pre-built ones, which I think is pretty helpful because it's pretty opaque without that. And so just to, show that, hey, that was just one button and we've got, all of our airflows assigned and, we're ready to start laying out diffusers. What's the workflow for accepting an updated architectural model with floor plan revisions? How do room changes get incorporated into the load model? That's a great question. So as architects get better with BIM, they start making larger and larger changes later and later and later into the model or into the project, which I know is very frustrating. So depending on how the architect is making those changes, these rooms may or may not, or these spaces may or may not explode. So if an architect deletes a wall, a room might explode. But let's say for instance, the architect added this wing. Oh, it's gonna tell me, doesn't allow me to delete spaces that way. So okay, so now I've got those spaces out of the model. Okay, so let's assume we were working, the building was going to look like this. We were working on it. We have our spaces placed. We're good to go. And then now we get a new model in, and the architect added all these new rooms, and we didn't have spaces for that. So if I hit the rooms to spaces button again, it's going to still look at all of my spaces, but where I already have spaces, it's going to ignore it, and it's just going to add them where I need them. And it'll also change the heights of the existing spaces if ceiling heights change or whatnot. So you can run the rooms to spaces button as the project progresses, and it will update only the new spaces. And there's no ceilings on the first floor for this project, so there's no new plenum spaces. It was just tall spaces. So as you get updates, you can keep running this. Now, if the architect is deleting spaces, you're going to end up with, like this said, hey, not placed, and you delete those spaces as you go. But it is built with being able to continuously run this button over and over and over again as the project progresses. Okay, there's a question about how do I get the schedules? I installed the software, but the schedules are not in the model. So in order, these don't get imported right when you open the model, because otherwise every model that you opened, it would have to, you'd have these schedules. So as soon as you start running functions, like when you run the room to spaces functions, it will import all of these schedules. So run a couple functions and these schedules will get imported. Okay, another question. Does the load also take into account building orientation to true north? Is it dependent on how the architectural model, or can the building be forced overridden to the correct building orientation? Yes. So this is also something that the architects are typically getting right. So typically all you have to do is let's see, analyze location. There is a way to so this will tell you what, so your location will tell you what's the assumption angle from project north to true north. So true north is a 45-degree angle, but this project's been rotated, to be orthogonal. So that will tell you that, and that comes from importing the architect's shared coordinates, which I think is in a different tab. But just while we're here, you could also override weather. Now this only applies to the built-in heating and cooling loads tool, and you could look up other information. So I can't remember where how you import the architectural coordinates. I can't remember. I will shoot you an email after this and tell you where it is. But this is, the architect typically gets this right because they want their building aligned with the civil model, and the civil model's got to be right. So it's a good curated data. So that's typically the architect gets that right. Do we check mark the construction type of the exterior wall since we're changing it to existing construction type? Yes. So the question is, do we check mark the construction type of exterior wall since we're changing it to existing construction type? Yeah. So when I showed the energy model here, so this has been, since I reran these loads, this has been set back to code minimum. But when I wanted to when I wanted to set this to a different construction, I have to check override here and say, hey, override all exterior walls you find to this construction. If I don't click this and I leave this as overridden, this is going to use the actual architectural element to try to calculate the R value and the thermal mass. And since those are always, again, I've never seen an architect get these right, and sometimes they're horribly wrong, like R0, no thermal mass, nothing's been imported. It causes a lot of problems. So I always say override everywhere you can. So yeah, that's what that means. Override to this, and everything else is overridden to the building. If this is unchecked, this uses the actual architectural element, which is probably not going to work for you. Okay, the question is, do the load calculations also factor in the fan heat and ventilation load? The answer is no. So the loads tool, the built-in heating and cooling loads tool, is really set up to get you the space load. What is the load on the space? Not anything else. Not because the ventilation air for all of these spaces might be coming from one air handling unit. So that ventilation load has to be determined totally separately. So this is really just how do I get the cooling load on the space? And same thing with fan heat. So, if I want to, in my assumption on the supply airflow, it says, hey, I'm going to supply 54-degree air. That's how it's calculating the CFM. So the fan heat has got to be accounted for in the air handling selection, not in the load calculation. Okay, some other questions. Who are your sponsors? Will it always be free, or will there be expiration on the sponsorship? I'm not ready to talk about who the sponsors are yet. That'll be coming out soon. In my opinion, it will always be free. I'm getting a lot of interest from sponsors, and I can't see that changing. I don't want to make any promises, but I really assume that it will always be free. Does the toolkit work with Revit 2022 and 2023? Yes, absolutely. So the GUI, this button was removed in 2022 and 2023, but it's still in Revit. So to get it back onto your user interface, you can follow the instructions that are on my website. If you go to my website, there's instructions on how to get that back. So you can go here and you can get the built-in heating and cooling loads tool back in Revit 2022 and 2023. And like I said at the beginning, you have a lot of different, it's really a data aggregator. It's not a loads engine. So after you pull all this data in, you can export it to a GVXML. You could use the analytical energy model. You could do whatever you want. It's really to just pull all the data and let you review it quickly. Does the constructions manager edit the original construction.xml file so new items are added? Yes. The construction manager edits the original constructions.xml file. Yes. So the new items are available for the next project you do. And you could also, if you have a one-off project that you need to build constructions for, you could also delete the constructions that you make. Open. So we just made this exterior wall and this material. I'm going to delete that material. And so it's going to tell me, hey, you've got an existing wall that uses this material. Do you want to delete them both? And I could just say yes, and it updates the file. So you can keep it clean and you can remove what you don't want. What are the additional tools on Ripple's development roadmap? So the next tool that should be released soon is a automated diffuser layout tool. So now that you have all of the CFMs assigned to the model, the next task is laying out all the diffusers. So it's a really cool tool. It will align your diffusers with the ceiling grid. It will decompose your space, so it'll break spaces down and address them separately. It's a really cool tool. If you want to be on the early access for that tool, shoot me an email, and I will get you on the list. That should be ready for early access in the next 2 or 3 weeks. So shoot me an email. Then after that will be VAV selections and ventilation calculations. So now that I've got the loads, how do I actually get the ventilation at my air handling unit? And how do I size my air handling unit? And how do I size all my VAVs? So the next question is, Revit itself doesn't allow a space to be zoned twice. So you can either zone spaces to an AHU or do VAV zoning, but not both. Is there a way to achieve zoning within Ripple, or is there something in the works for the future? You mentioned the VAV selection programs. Yes. So that is exactly right. Yeah. The out-of-the-box Revit HVAC zones are not helpful. They never defined if they're supposed to be VAV or air handling unit, and they have elements of both in there, so it just made them not helpful. So when you're using the toolkit, disregard the HVAC zones. Yes, when the VAV and air handler zoning program comes out, that will have new parameters that allow you to zone based on that parameter. So that will be, that's something that's in the works that'll be out after the diffuser layout tool. Set code minimum construction types assigns IECC, International Code Council construction types. Is there a way that we can go with ASHRAE 90.1 construction types? Yeah, so they are the IECC construction types are the ASHRAE 90.1 construction types. So that's doesn't have anything to do with Toolkit or Revit, just that you know, the IECC pulled all of their minimums from ASHRAE 90.1. So if you go to ASHRAE 90.1 Appendix A, you'll see that this is the assumptions they made when they were making their code minimums. So IECC and ASHRAE 90.1 are synonymous. So the next question is there functionality to find heat loss through the floors? So if you have, you know, a floor, let's look at an elevation here. So if you have like this and you have a floor here and you have 2 different spaces at 2 different temperatures, it will calculate a load through that floor. It will not calculate a load to grade. So when this engine was built, ASHRAE with the radiant time series method they didn't have a calculation procedure on how to do this. So they don't account for heat loss through the floor. So my opinion on that has always been that, you know, the ground, what's the lowest temperature that this ground can be? And it better not be below freezing, because if it's below freezing, this is not a slab. This is just going to be rubble in too long. You're going to have frost heaving. So the delta T between these, it should never be too great. And then it's always going to be it's always just going to add heating load. So like, because I always assume no internal loads or anything for heat loss through the slab, not only is this load going to be very small, but like just the lighting load is going to be way more than, you know, any load that this can be. So as long as you're not taking credit for lighting in your heating load calculations, you know, you really shouldn't be too concerned with the floor heat loss through the slab. Okay. So it looks like some of the specified CFM were overridden to 0 for somebody that's tried this out. So again, if you go to the space type additional data, provide supply air is a yes/no parameter here for each space type. So for example, plenums, you never want to provide supply air to plenums, so this box is unchecked. So even if there's a load on the plenum, the round and assign override CFM is not going to assign any CFM to the plenum space. I only wanted the plenum space there to get the load. I don't want to assign any CFM. And same goes for paint spray booths, toilets. A lot of times you just exhaust those. You don't provide supply air. So I have these unchecked by default. If you want supply air CFMs assigned to those, check these boxes. And then now the round and assign override CFM will assign CFM to that. Can you enter infiltration as cooling or heating gains? Yes, you can. That is in the heating and cooling loads. There is a building infiltration class, and I have this default set to none. I'm always a proponent of giving your building a little bit of slight pressurization to make sure you don't have infiltration. If you want to see what those settings are, I don't know if they tell us. So they have loose, medium, and tight, which you want to see what those settings are, you can go to the set settings, hit F1, and then scroll down to the building infiltration class. So loose is 0.076 CFM a square foot, medium is 0.038 CFM a square foot, and tight is 0.09 CFM a square foot, and none is 0. So yeah, those are your 3 options. It doesn't get any tighter than that. You can't enter your own value. Next question is, will all of your tools be sponsored and free, or just a toolkit that you demoed today? So all of the tools will be sponsored and free. How do you handle rooms that are partially below grade? Okay, so so you can handle rooms that are partially below grade, and that is dictated by the ground plane. So anything that's below the ground plane will be assumed to be a below grade wall, and that will use your